This is how online lab looks on an interactive board product from Icat board.
Oh, adesso tu quanto sei?
We open. Touch the real-time trend.
Очень ясно. Хотелось сразу.
Tu je prekida, sad ide recording.
Da, okej. Uključeno.
Onda ako bude cijel prekid samo ovdje na ovome isto. Znači reći. The level is increasing. So it will go on until the set point for level 1, which is 15 centimeters, and the red line is set point. So we see that pump 4 is on, which is pumping the fluid from the reservoir to the tank 1. So now it's 15. There's the set point, the small overshoot. So we shall have a small overshoot, and now controller is controlling it to 15 centimeters. We can see also the alarms. We didn't have any alarm. Yeah. So we had a high alarm, and we can acknowledge. Now the high alarm is acknowledged. 11:58 time when it happened. 56 seconds, 671 milliseconds gone. This is the activating of the horn, on and off. And now we had the low alarm. You can see the horn. The controller is controlling the level. And we can switch on the live camera to see how the video is showing. At the moment the camera is not on, but this is for video feedback. Of course we can change the interface language. Now it is English, we can switch to Bosnian. Now the labels are in Bosnian. If you want to send email, you can send email to any person informing about the events in the process. Or if we are controlling the temperature of water, we can set the temperature. It's for nice increase, and this is for rough increase of the temperature, or switch manual, because it's in manual position. We can manually switch heater to warm the temperature, or fan to cool the temperature of the water in the reservoir. And decrease set point, or change to auto. Now it's control, it's in auto position, and we can also switch it on and off. So this is the pump which is pumping out from the third tank. Now it's on, and now water is opening the valve to return the water from that reservoir to from the tank 3 back to the reservoir. Here also we can switch the pump, and now the outflow of the water from tank 1 is not only gravitational but also forced with the pump, so it will go faster. The level here will increase faster in the tank 2. You can see the trend. Here, level 2 is wide and it's increasing faster because we switched on the pump as well. Pump 1 and pump 4 are all on the green, and the other 2 are off. So if you want to see how the network topology looks like, we have it here. We see that the plant with these 3 vessels and the pump with the reservoir is connected to Siemens PLCs, similar to that one here. So this Siemens PLC is getting information on the levels in 3 reservoirs and giving the control signals on these pumps to switch them on and off, also controlling the temperature of the vessel. Now this PLC is connected to PC, which is running Windows CC control center, that's HMI software from Siemens, and then we are using OPC protocol and communication to transmit all these real-time data from the PLC to second PC, which is now putting it all on the web, on the internet. And we can send live screens like this one, and also to control anywhere from the internet using either wireless network for the local users who has wireless connection to this server, or we can send it through local network in other parts of the university, like this one on the LAN network, or send over the internet like here now. We are connected over the internet, so we are somewhere here now on Elijah, and this is at Faculty of Electrical Engineering where the plant is and this server. Also, we see that the alarms of the plant, of the high level and so on, can be sent to any operator via mobile network, so we can send SMS messages to operators which are on duty to be informed that there is alarm in the plant, or if it is monitoring the patient, you can send the mobile SMS message to his doctor to come if the patient has high pressure blood or high rate of heartbeats and so on. So we use systems not only for monitoring and control or remotely the industrial plants, but also for monitoring patients in the hospitals, for the wards in the hospitals, the urgent life support systems and so on. Also we can send all these informations. Also we've seen that how we can send the emails to any recipient over the internet if somebody has to be informed that there is a trouble in the plant, and then he can be warned either by mobile phone or over the internet if it is having trouble. So the main operator can be at home and he can switch on his PC and then take over the control of the plant. We did it on many plants in refineries for the main operators which are not on duty at night, and there is a big trouble that the operator on duty can't solve. Then they send message automatically to the main operator who is at home, and he switches on his PC and takes over the control of the plant. Yeah. Also, we can send all the information over the internet to any part. For instance, we are having now several refineries in Libya, which we have designed the system, and we are now here from Sarajevo controlling the operation. So if there is any trouble in the plant, we get automatically information on that, switch on and intervene from Sarajevo if we have any problems with the systems down in Libya or refineries or any other location in the world. So this is, and this interactive board is very good for that, because if you have other people to teach or explain your system, or if you want to consult or collaborate with other people, if you have several people and you are discussing the problems with your plant, then you can get them all in front of the interactive board and discuss what could be the cause for that alarm we have and what we should do to get rid of it and so on. So that's I found very useful for this kind of, we can get also historical alarms in any part in the months of last year, last day and so on, or we can see how the plant was changing in time, like historical trends. It takes some time because there is a lot of information that has been transferred from server to this location. So historical then take